Tomek, go on.
Hello, guys. As you know from the announcement, I'm Tomek. I'm working at Software Mention, and today I want to tell you about the toolkit that we created that was mentioned on the first presentation by David. And this is a bit of a clickbaity title because I don't know how many of you guys know Foundry. Raise your hand if you do. Okay, so we set out to make a tool that is inspired heavily by Foundry, and we wanted to make it better. But did we make it? Let's see. So I want to introduce you about to the team at Software Mention, which is called Crypto Mention. Like it's a pretty common pattern that we saw in crypto space that people are creating subsets of their own companies. So I think the idea was just to call ourselves Crypto Mention. So prior to Starkware, we have been working on some crypto projects, but not much. When we started working with Starkware last year, we were just 2 of us, and now we're 14. So that's pretty huge for us. And yeah, so we're relatively new to that space. And for Starkware, we're making SDKs and developer tools and also writing Cairo contracts. So let's talk about the genesis of the project. So first there was Cairo-lang. It is obviously a language. It is really primitive. It has a lot of syntax sugar sprinkled on it. It can do basic operation that any programming language can do, like recursion and with jumps, etc. No strings, no that fancy stuff. Only one data type called felt. It is pretty difficult to learn because of that, but we are working on educating the users on how to learn it more efficiently to make that steep learning curve a bit smaller. This is a language that was developed with proving in mind, so that is why it is so bare bones, but like David said, it's also really performant. So the tooling for Cairo is still maturing, and there are not a lot of tools. When we started, we were basically the first to try to develop a testing framework for that. So the state of the art at the beginning of our project, user wanted to test a contract, but what he had to do was basically write Python code, which is like using JavaScript for solidity tests, which I to this day don't understand why it's done like that. So some rudimentary tools for testing were available, provided by Starkware, like the testing framework, but it still had to use Python. And also, there was no solution for managing your projects. So there's Foundry in Solidity, and as some of you may know, it uses Git submodules to manage the dependencies. So we thought, it sounds pretty simple, why we don't do that too? And we set out to solve some of the problems that were apparent in the space. So just about a year ago we started, and I think it's been a pretty wild journey. So what is Foundry really, for those of you that don't know? It's basically a Swiss Army knife for Solidity, and it's implemented in Rust, and it's known to be, it brags its efficiency, and it's kind of interesting from testing standpoint, and you don't have to use JS to run your tests. So that's something that we also wanted, to not have to touch Python, which is coupled with Cairo 0 as well. Okay, so in Solidity, the most interesting features were testing with cheat codes, like the operations that it allows you to do is illegal normally on the blockchain. That's why it's called cheat codes. With basic test setups, also fuzzing, yeah, and dependency management with Git submodules, like I said. Some blockchain interaction and interesting profiling features like showing how much gas your test consumed. Okay, so protostar. We kind of copied a lot at the beginning from Foundry. So we did contract-based tests. So basically your test is a contract. And adding, removing dependencies through Git submodules. We also had a project configuration file written in TOML, which is, I think, we kind of improved upon Foundry because it has some pretty interesting features for using different profiles for your CI, for your test environment, and for the production. And also, we implemented our own fuzzing and parametric tests, and Starknet interactions to deploy your contracts, interact with them, call them, etc. Okay, so how does it look like? So this is a slide of code. I promise you, there are only two. This is the TOML configuration file, and it consists of a few sections. You can define your contracts, you can configure your commands, and also commands with combinations with different profiles. And it all works really neatly. We're proud of it. And this is the test code itself. So I tried really hard to fit this into one screen. Forgive me, Cairo 0 is really verbose. So here there's a simple test written with usage of protostar's features. There is a setup at the top called this setup function with underscores. This setup works for executes basically for each test case in the file, like setups in other testing frameworks. And there is one test case. And then we have some cheat code usage. So right here, cheat codes are deploy contract and also warp. Those two are basically used to declare and deploy a contract from the code directly, which you can't really do normally, because declaration has to be a separate transaction. And warp is setting block time to the time specified. And that's basically it. And as you see, there's minimal Python involved because the hint contains Python. Okay, so this initial version has been a success. We achieved the target. Didn't touch anything but one language, and you all needed Cairo and protostar. So let's talk about some pitfalls. Git submodules was one of the biggest of them, because of course you have to enforce Git, and if you're already using Git, it can be kind of confusing, because you have to add some commits on initialization of the repository if you're adding new dependencies via protostar or via Foundry. And also, you have to use Git as well, since other people are using other VCSs. This is not optimal. There are a lot of corner cases. I believe to this day we haven't found all of them, and I hope we do not find them never. And it's kind of hard to grow and maintain because we're limited to the feature set of Git. Okay, so the second is cheatcode naming. For the users that know Foundry, the naming is fun. If you know what cheatcode does, it's simple to write. But also, a lot of people were coming not from the Ethereum even background, so they have no idea what they did. We tried with improving the experience with the documentation, but yeah, it's a problem that occurs even with our developers inside the company. So yeah, so I have a riddle for you. What does that do? For those that don't know Foundry, of course. Does anybody know? Okay, so a hint, it does illegal thing on the blockchain. It changes the identity of the caller. It's really not obvious, and when you see it first time in the code, it can be really confusing. So there is also like a more complex problem that we encountered with contract-based tests. There is lack of distinction between end-to-end tests and unit tests. And because of that, many users were using the very heavy deploying contract than testing the deployed contract. In reality, it was easier and lighter to run a test which only imports the functions and test them directly in your test contract. And in general, Python is not very fast, but I believe that ecosystem is changing rapidly, and that is something that we also have in mind to improve. So the second thing is the approach is poor caching capabilities. Because the test is a contract, we have to always recompile the whole thing, and there is no way to cache this anyhow and bring the protostar any closer to the Foundry performance. And basically, we kind of tried to optimize it, but it was impossible from like theoretical standpoint. So we redesigned the whole thing, and I think it's still work in progress, not deployed yet, but I think we've pretty much solved the issue. And also Python executables. One of the things that occurred to us when beginning the project is that installation of Foundry is really fast. It downloads almost instantly, runs almost instantly, and has a lot of built-in features like Windows support, which we don't have because our implementations don't allow that. And it's also not ideal solution for a CLI-based tool. So if you want to build a CLI-based tool, don't use Python, my advice. And some of the issues we could solve and some we couldn't. So we decided to ditch the Git submodules completely. And we proposed to Starknet to build a package manager from scratch, which is called Scarb. And it has everything that Git submodules can do and even more because it's tailored to Cairo 1. It's really awesome, growing really fast. And yeah, I think it will be awesome. So boosting performance is really a topic that that we always kind of push to. And we always try being close to Matter whenever possible. When obviously, when running a blockchain-based application, hashing is always going to be our bottleneck. So we try to use native implementations there. We try to educate users to write optimal tests, but that is kind of really hard because everyone wants to deploy their contract and then test it. It's really intuitive, but not optimal. And yeah, we also as we go, we benchmark and identify the issues. Yeah, and the user feedback is really important for us as well. So the new architecture I was talking about, it's kind of ditching the Foundry-like contract-based testing, which means that your test isn't a contract anymore, it's pure Cairo code, because in Cairo, you don't have to define a class, like a contract class, to implement anything. You can just define your functions, mark them as test in Cairo 1, and everything becomes suddenly easier to cache and more straightforward to the user. Yeah. So migrating to Rust. Yeah, this is a topic that that is really hot right now in Cairo, because from Cairo 0 to Cairo 1, we're going to Rust implementations everywhere. So obviously, protostar is also migrating towards Rust. It's not a straightforward process, but yeah, in a couple of months, I believe we can achieve this. We can finally support Windows out of the box, which is awesome, because I know people requested it. Also, smaller binaries. Right now, our binaries are pretty big. And we're going to be blazingly fast, like this hello world. So, what's next? As you see, we have a long way to go to improve upon all of those. And we have a lot of ideas from the community, which has really helped us to... we wouldn't have thought of all those features if not for the community. And it's really encouraging to see how Starknet community quickly grows, and it's really active. So forking network state for tests is something that we'd like to do. Cross-chain testing is like, the simplest way to explain is to have L1 and L2 basically standing next to each other, talking, passing messages, etc. So we can test end-to-end. If you have your contracts on Ethereum also, you want to bridge something to Starknet, we want to facilitate users that with the tools that can do that. And also code coverage. This is missing in Cairo as of now, and yeah, I think we're gonna try to tackle this one as well. So this presentation's title was doing something better than Foundry. So are we better than them? I don't think so right now, but we're different. We have learned a lot. It was like the first tool of that kind that we built, and we learned our lessons from that, and I think it's going in the right direction right now. Okay, so I hope that you liked the presentation. Thank you all for coming to our humble office. And if you would like to get notified about similar events at Software Mention, I encourage you to sign up to our mailing list with the QR code on the screen. And also, if you want to know anything more, just hit us up on either Telegram or tag us on Twitter, GitHub. We're really active all across the board. Thank you.